Okay, so this video is to go over your second 6 weeks cumulative test so that you are prepared for the reassessment. So problems 1 through 5 on both tests were the same, so we're going to go over problems 1 through 5 first. So number 1 says identify the vertex for the graph f of x equals x squared minus 6x plus 14. So to do that, you can use the formula x equals the opposite of b over 2a. So in our case, the opposite of negative 6 is 6 over 2 times 1. So that means the x part of my vertex is going to be 3. So answer choices C and D are now eliminated. And to find the y part of my vertex, you have to plug in this 3. So f of 3 equals 3 squared minus 6 times 3 plus 14. You have a calculator handy, I'm sure, so you could type this in. I don't. So 9 minus 18 plus 14 is going to get me 5. So now my vertex would have to be 3, 5, which is letter A. Number 2 was a long division problem. So we're going to take 2x plus 1 and divide it into 2x squared plus 3x plus 1. So to make my 2x look like 2x squared, I need to multiply by an x. X times 2x squared is 2x squared, and these match, which is exactly what we wanted to happen. 1 times x is plus x. Be careful, you are subtracting the entire quantity. So 2x squared minus 2x squared is nothing. 3x minus x is going to make a 2x. And then I'm going to drop down my plus 1. To make 2x look like 2x, you have to multiply by a 1. 2x times 2x is, 2x times 1 is 2x. And 1 times 1 is 1. Be careful, you're going to subtract the entire thing. 2x minus 2x is nothing. 1 minus 1 is nothing. So my remainder is 0. A lot of you did beautiful division, except for the problem asked you to grid the remainder. Well, this right here that I'm circling, it's not the remainder. You guys were like, how do I grid x plus 1? You don't. Your remainder down here is 0, and this is the number that you should have gridded on your test. And number 3 did much better. It wanted you to do synthetic division. The only trick to this is that negative 4 has to go in the house, and that's because when you do x plus 4, when you do that factor and you set it equal to 0, x is going to equal negative 4, so negative 4 is what we put in the house. Then you're going to write down your coefficient, so 1x cubed, 5x squared, 2x, and a 1. We drop down our 1 times 1 times negative 4 is negative 4. Add 5 plus negative 4 together and you get 1. 1 times negative 4 is negative 4. Add these together and you're going to get negative 2. Negative 2 times negative 4 is going to be an 8. 8 plus 1 is 9. This thing that I'm circling in red right here, this 9 is your remainder, and that's what you should have gridded for number 3. Number 4 says, find all the complex zeros for the polynomial function using the quadratic formula. So you were given the quadratic formula, x equals the opposite of b. Oops. Let's try that one more time. The opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. So when you plug it in, you're going to get that x equals the opposite of b, the opposite of negative 2 is 2, plus or minus the square root of b squared, so 4 minus 4 times 1 times 5, all over 2. This piece right here, if you were to type it in a calculator and simplify it down, is going to get you a negative 16. So now you have x equals 2 plus or minus the square root of negative 16 over 2. We can't square root negative numbers, so you get negative 2 plus or minus I square root of 16. That I takes care of your negative. The square root of 16 is 4. So you're going to get the x equals 2 plus or minus the square root of 16, we said was 4, so 4i all over 2. You divide both pieces, both of these numbers have to be divided by 2. And you're going to get the x equals 1 plus or minus 2i, which means your answer was letter C. Number 5 has I to the 24th power, I to the 24th. So you're going to take 24 and you're going to divide it by 4. That equals 6 with no remainder. So if you had a remainder of 1, it's I to the first. Remainder of 2, it's I squared. Remainder of 3, it's I to the third. But when you have no remainder, it goes in evenly. It's equal to I to the 4th power. I to the 4th is the same thing as I squared times I squared. I squared, we know, is equal to negative 1. So negative 1 times negative 1 is simply a 1, and the answer was, again, letter C. Okay, so now on number 6, there were 2 different versions, so 2 different problems. Same question, different functions. So on one version, you have that negative 3x to the 7th minus 12x to the 5th plus 6x minus 5. And it says use the equation below for numbers 6 and 7. Number 6, identify the maximum number of turning points and the maximum number of real zeros. This biggest power, the biggest degree, is always my number of zeros. So the number of zeros in this case is 7. Now to find the turning points, you always do the number of zeros, which is known as the degree, minus 1. So number of turning points is 7 minus 1, which means my answer is 6. If you had the other version of the test, your problem was that you had 4x to the 6th minus 12x to the 5th plus 6x minus 5. And it's the same thought process. The biggest power right here is 6, so that means my degree is 6, which is the number of real zeros. And then again, you do the number of zeros minus 1, so 6 minus 1 is going to equal 5, and that's my number of turning points. Okay, so now for number 7, I'm going to go back to my negative 3x to the 7th version minus 12x to the 5th plus 6x minus 5. It wants you to describe the end behavior. So again, my degree is 7. That number is odd, which means that my ends have to go in opposite directions. So normally, it would go like that. That's the worst graph ever, but you get the idea. However, this leading coefficient here is negative, so that's going to flip-flop my ends. So the left side's now going to go up and the right side's going to go down. So now I have to find the equation that says that. And so what you want it to say is that as x approaches negative infinity, f of x goes towards something, and as x approaches positive infinity, f of x goes towards blank. Well, if you look at your graph, as x gets negative over here on this side, the y value is going up. So your first one should have an infinity. And as x gets positive, this side goes down, so this one should have been a negative infinity. So your answer was letter A. On the other version, the 4x to the 6th minus 12x to the 5th plus 6x minus 5, your degree was 6. That's even. That means that both ends have to go in the same direction. My leading coefficient here is positive, so both of my ends are going to go up. And again, that means that as x approaches negative infinity, f of x goes towards blank, and as x approaches positive infinity, f of x goes towards blank. Both my ends are going up, so both are going towards positive infinity, and you were looking for letter D on your paper. The next problem on one of the tests said, write a third-degree polynomial in factored form with zeros of 3, which had a multiplicity of 2, and negative 6, which had a multiplicity of 1. So, f of x equals, if I have a 0 of 3, that means x minus 3 is a factor, and this multiplicity of 2 means that my degree on this factor is 2. And then I have x minus a negative 6, which is going to make an x plus 6, and it has a multiplicity of 1. So that's the answer on the first version of the test. The other version said to write a third-degree polynomial in factored form, and it says that I have zeros of negative 4, so you would have had x plus 4, which had a multiplicity of 2, and x minus 5, which had a multiplicity of 1. And there's your answer for the other version. Okay, the next part of your test had a graph, and then there's 3 problems. So I'm going to insert the picture of the graph. So on one version, this is the graph you were given. And then it says, is the degree of this graph even or odd? So if this is the graph that you had, this is definitely even, because both ends are in the same direction, up. Even if both ends went down, it would still be even, but as long as the ends go in the same direction, it has to be even. Then it says, is the leading coefficient positive or negative? In our case, it has to be positive because both ends are going up. And then it says, what do the real zeros of the graph appear to be? So this is a 0, this is a 0, this is a 0, and this is a 0. So my zeros are negative 3, negative 1, 1, and 3. On the other version of the test, you have this graph. This is definitely odd because the ends go in opposite directions. Remember, odd functions normally go down and then they go up. This one goes up to down, which means my leading coefficient had to be negative. And if you want to look for my zeros are where I touch the axis, so right here and right here. So negative 2 and 3. Next problem on the first version said, write the function of degree 3 in standard form with zeros of 3 and 2i. So it's implied that if you know that 2i is a 0, so x minus 2i, that you also have x plus 2i, and then I have my x minus 3. I am going to FOIL these two together first. X times x is x squared. X times 2i is a positive 2i. Negative 2i times x is a negative 2i x. Negative 2i times positive 2i is going to be a negative 4i squared. This and this cancel off. This I squared right here is negative 1. So I really have an x squared plus 4, because negative 4 times negative 1 is really just going to be a 4. And then I still have my x minus 3 that I have to multiply by. And I'm just going to FOIL these together. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. 4 times x is positive 4x. And then 4 times negative 3 is negative 12 equals f of x. And it says to write it in standard form. That means it's all multiplied out. And the powers are in descending order, which it is. The other version of the test was very similar, except it had f of x. It says that the function of degree 3 in standard form with zeros of 4 and negative 2i. So again, you have this x plus 2i, because x minus a negative 2i is going to be plus 2i, which means you also have x minus 2i. And then this time you have x minus 4. Well, on the previous slide, I just FOILed these together, so we know that it's going to be x squared plus 16. And I have to FOIL that together with my x minus 4. X squared times x is x cubed. X squared times negative 4 is negative 4x squared. X times 16 is 16x. And 16 times negative 4 is going to be a negative 64. Okay, the next problems, 13, 14, and 15 for the first version, gave you that f of x equals x minus 2 over x minus 3. 13 says, what is the vertical asymptote of the above equation? Well, the vertical asymptote is any factor in the denominator does not cancel out, or that is not a whole. This is going to be how I find my vertical asymptote. So you're going to take x minus 3 and set it equal to 0, and you're going to get that x equals 3. I need you to hear me when I say this. So many of you on your test wrote x cannot equal negative 3. And yes, that's a true statement. We are never, ever, ever going to touch negative 3. However, this question wants the equation of the vertical asymptote. This is the equation of the vertical asymptote. This thing is part of the domain. So please make sure when you're writing the equation of asymptotes, you cannot put does not equal. It actually equals it. That is the equation of it. The next question says, what is the equation of the above? What is the horizontal asymptote of the above equation? Well, if we look at this, the degree of the top is 1. There's a 1 on my x up here, and there's a 1 right here on my x in the denominator. This is each DC. The exponents are the same. We're going to divide our leading coefficients. The leading coefficient's the number out front. In the numerator, it's 1. In the denominator, it's 1. So 1 divided by 1 is 1. So y equals 1 is my horizontal asymptote. Make sure you know that vertical asymptotes are x equals and horizontal asymptotes are y equals. And then you get to the last problem that says, what is the domain of the above rational function? That's where we're going to go in and use this. I agree that x cannot be 3. Domain is my x stuff. So to write my domain, the smallest thing I can be is negative infinity. So I'm going to go from negative infinity, and I'm going to keep traveling along my number line until I get to 3. I can't be 3, so I'm going to jump over it and go from 3 to infinity. We no longer are going to accept domains that are written like this, guys. It has to be in interval notation, just like this. The other test had that x squared minus 9 over x plus 5. And this one requires me to factor the numerator. X squared minus 9 factors into x plus 3, x minus 3. Difference of two perfect squares, you should know this, over x plus 5. There are no common factors in the numerator and the denominator that are going to cancel off. So again, this thing right here is going to be my the cause of my vertical asymptote. I set it equal to 0, and you're going to get that x equals negative 5. This is the equation of my vertical asymptote. Again, do not put x cannot equal. It is x equals negative 5 because that is the equation of the asymptote. If I go back, the power of the top one is a square. The power of the denominator is a 1. So this is a big on top, none. So there are no HA or no horizontal asymptotes. And the last question says to state the domain. So we know that x cannot be negative 5 because that is my vertical asymptote. So my smallest thing can be is negative infinity. And I'm going to travel along until I get to negative 5. And I'm going to jump over negative 5 and keep going along my merry way all the way to infinity. There is your domain. If you have any questions about any of this or you need help, it is super important that you go to tutorials. If you failed your 6 weeks test, you're going to have the rest of today in class to study, tomorrow in class to study, go to tutorials, ask questions. There's late night library Monday night from 3:30 to 5:30 in the library. Ms. Stiles will be there. She can answer your questions. Wednesday in class, if you failed your 6 weeks test, you will be granted the opportunity in class to take the reassessment, and hopefully you get up to a 70, and that will bring your grade up to passing. If you have any questions, again, make sure that you ask.